Hey everyone, so this is going to be our very first unit of kinematics and the very first topic where we're going to talk about the concept of position, distance, and displacement and how we can use these terms to talk about where an object is and start talking about how they also move as well. Just getting off to everything, let's define these definitions. So the terms are position, which is represented by an x in a lot of equations, and this is essentially your physical location relative to some reference point. What is a reference point? You can imagine as if you're looking at a graph, and just as how you can say a graph might start at some position on the y-axis or some position on the x-axis, that's the idea here. You can imagine the world as being on imagine a picture being on this two-dimensional graph, overlay it on there, and then your position would be where you are on the graph. And I'll show an example of what I mean by that. Distance and displacement are both concepts of how you end up moving. So position is just where you are. Distance and displacement is how you go between two different positions. Distance, which is very commonly represented as the symbol d, represents the total length of the path you travel. So you go left, you go right, you go up, then you go down. Distance would be that entire path. Displacement, sometimes represented as delta x, this symbol just means change in position, is the straight line distance between where you started, like your starting position, and your ending position. And like I said, sometimes we also call this your change in position because that's essentially what's going on. Now, one thing to note, there's a few things actually. First off, is that all three of these terms are measured in meters. So your position's usually some meter location from some reference point. The distance is some meters that you travel. Same thing with the displacement. Another thing I should point out is that in a lot of cases, these three terms are interchangeable. You're going to see a lot of cases where distance and displacement can be the same thing. There's very few cases where you actually have to be very careful about whether you're dealing with distance or displacement. But they all kind of refer to the same thing. Like I said, position is your physical location, and displacement the you know moving between two different positions. Same thing with distance. All right, so what's one of the differences between position, distance, and displacement? Now, position is, like I said, just your location relative to some point, some reference point. Now, this indication or can sometimes include a direction, whether you're ahead or behind it, to the left or to the right of this reference point. And like I said, a lot of times you can just kind of graph it, put it onto a graph and kind of visually see it that way. One example, and I'm going to use this pretty much the same example for all three of these terms. Imagine you were running around a track, you're going to do 8 full laps. You could talk about your initial position depending on where you started along the track. If we talk about the starting line as being zero, and you start at the beginning point, then your initial position would be 0 meters. But if you started 10 meters ahead of that starting line, then your initial position would be 10 meters. That's it. And then, if you started behind, it'd be 10 meters behind. Now, this is what I was referring to when I said you can put it onto a graph. So here we have a picture of a ball being thrown up into the air. It goes up and then comes down. And it shows a few different points along its path. One thing we could do is just place a graph on here and pick a certain location to be what we call the origin point, the 0 point, as our reference. So here, the initial point where the ball's being thrown up, we're saying is 0, and then we could say, okay, this point, when it's at this point, this would be its position, 8.1 meters. When it gets to this point, the position 6.4, and then down here we get into the negative side. So this is kind of the idea of the concept of position and the idea of overlaying a graph onto the scenario. These are some other examples. And here we could see, we have two runners. And again, one runner is at a location of 10 meters at some point, and then the other one is located 30 meters. Where's this reference point? It doesn't really matter. What matters is what's going on, the relationship between these two pictures. You're going to see more examples of this later on. So I'm just kind of throwing this idea. And if this is confusing you, don't worry. It's going to come. We're going to talk about it in more detail later. It's just there's not really a whole lot of simple diagrams that have these nice types of graphs. All right, so now distance. Now, distance will tell you the entire length that you travel, but the problem is that it doesn't discriminate uh, whether you went into circles, whether you backtracked, or what direction you're going in general. So, in the example of running around in the track for 8 laps, you'd end up running a total distance of 2 miles. Now, a lot of the times in that track, you going in opposite directions. One time you're going to the left, and then another time you're going to the right. You're going up, then you're coming back down. A lot of your laps are kind of canceling out, but distance doesn't care about that. You could go forward a mile and then reverse for a mile. It's you still traveled a distance of 2 miles. Displacement, on the other hand, actually does care about that. And basically, like I said before, it's the distance between where you start and where you end, and your those two positions. So if we go back to the track question, going around in a circle 8 times, well, our total displacement would actually be 0 this time because we're starting and ending at the same position. And the distance between those 2 points is 0. It doesn't matter that I went around in a circle and that I actually did move. What matters is where I start and where I end. So these two pictures kind of show that point for the most part. So here we can see the distance kind of is this windy turning road, while displacement is a straight line going from start to finish. And then here's another example over here. And you could see here the distance is extremely big while the displacement is very small. Now, a quick side question would be, in what cases would the distance and displacement be the same? All right, so here's the first question. Pause the video, work itself, and we'll go over in a second. All right, so in this question, they want the player's total distance. Now, we do have to pay attention to the phrasing. To go from one basketball net to the other basketball net is 30 meters, but it says that the person goes there and back and then does that 3 times. So he travels a distance of 60 for each lap, and then he does that 63 times, which gets us a total distance of 180 meters. What's with the 60 seconds? Not necessary. Now, one thing I did want to point out before I continue is that a lot of these questions that we do, they start off a lot times as regions level questions. Sometimes I try to focus on a little bit more of the trickier regions, and they do kind of build up to more AP style. So I do want to mention that this is a regions style question. All right, here's another question. Pause the video, work itself. I'll go in a second. All right, so what they want us to do is compare the total distance traveled by a player compared to the total or the total displacement compared to the total distance. Now, just to clarify what this actually means is they really want us to find the difference between them. They want us to figure out, are these the same numbers? Is one of them bigger or is one of them smaller? And if so, how much? That's kind of what they're asking. So let's actually try to figure out what the distance and the displacement are. The baseball player runs 27.4 meters. He overruns it by 3 meters, and then he returns back to the first base. So he goes 3 meters forward and then 3 meters back. When it comes to distance, we're just going to straight add all three of these numbers. So 27.4 plus 3 gets us 33.4. In the case of displacement, I'm going to have to do from start to finish. Well, from where he started at the batter's box to first base is 27.4. Now, it doesn't matter what else he does afterwards because I know he returns to the first base. The person could have went to second and then returned to first. Doesn't matter. All we care about is from the batter's box to first base because that's start to finish, and we know that that's 27.4. So the displacement's 27.4. Now in here, I basically had it plus 3 minus 3 to represent the idea that I'm backtracking. I went forward 3, but then I went back 3 to return to the first base. So the difference between the distance and displacement is 6 meters. So the displacement would be 6 meters less than the distance. And that's the actual answer here. Right. And that's all we're going to talk about for now. Just the idea of distance and displacement. Like I said, we just kind of want to talk a little bit about that in order to lead us into this next discussion, which we'll save for in class, which is all about scalars and vectors. Now, if you have any questions, feel free to let me know. Otherwise, good luck and have a great day.